Okay, so let's take a look at example 2. This is an example where the region we're looking for, the area, is lying between two intersecting graphs, okay? So the way that this example is different is you'll notice that they don't give us our endpoints, A and B, right? They don't give us those vertical lines that are going to bound the region together. And the reason why is because these two graphs actually intersect each other. Now you can go through the trouble of setting them equal to each other and finding the actual points where they intersect. But if you just draw a graph using an XY table for each, you'll eventually see where they intersect, right? And so that's what we're going to do. So before I find the area, I have to actually know what region I'm looking for and know my endpoints and my points of intersection. So I'm going to first sketch f of x. So this is f of x equals 2 minus x squared, okay? So again, I'm just going to do, since this graph was given to us, I'm going to do -2, -1, 0, 1, and 2, okay? So if I plug -2 in here, right, I should be getting -2 times -2 is +4, 2 minus 4 is -2, so that's here, okay? Then if I plug -1 in, that's +1, 2 minus 1 is +1. That's right here. 0, I'll get 2. 0, I'll get 2. 1, I'll get 2 minus 1, which is 1. Okay, and you should start to see this is an upside down parabola, and symmetrically we'll end up back over here. Plug in 2, we'll get -2. Okay. So if I connect those dots, looks like this. It's not perfect, but it's good enough. Okay, I can repeat that for my g of x function, x and y. Now, this is pretty straightforward, right, because x equals y. So when you do -2, -1, 0, 1, 2, -2, you plug in, you get -2. So you're just going to get all these values again. So what we'll have is -2, 2. That is our first point of intersection. -1, 1, 0, 0, and 1, 1. There it is. And that is our second point of intersection. Okay? So the area we are looking for, right, is between the two curves. So if this is one curve and this is the other curve, then the area we're looking for is right here. Right? Okay. So, by finding our points of intersection, we've actually found our a and b values of -2 and 1. So when we write this integral, it's going to be the area from -2 to 1, right, because that's where they intersect with each other, of f of x minus g of x. And again, don't just memorize the formula. It's f of x, it's the one that's on top, right, the higher one up here, okay, or else you're going to have some negative issues. So we got 2 minus x squared minus x. And now I don't actually need parentheses because that function is itself, so I don't need to worry about that. And then dx. Beautiful. Okay, so you can rewrite this if you want in descending order, but this looks fine to me. So what I'm going to do is integrate individually each time. And again, we're going to need to use the fundamental theorem of calculus after we do that. So the integral of 2 is 2x minus, here is the reverse power rule again, where n is 2, so add 1. That's x cubed over 3, and then this is to the first power, so it would be minus, add 1, x squared over 2. And again, we're not doing plus c. It's a definite integral, so we're from -2 to 1. And we need to apply our fundamental theorem of calculus to get the answer. So it's FB, which is the top one, minus FA, which is the bottom one. Okay, so let's find F1 first. 2 times, again, we're plugging 1 in wherever we see an x. Okay, minus F2, F of -2. Okay, that looks like 2 times -2, -2 cubed over 3. Now, when you go through all that simplification, what you will end up with is, well, I'll do one step. 7, 6 minus negative 10/3, which should give you 9/2. Okay, and that would be our final answer. And that's example 2. Got 2 more to go.